Welcome to Physics and Mathematics Lovers. Before us here is a question on mathematical induction. So the question says, using induction principle, prove that the following statements are true. So like I said in my previous video, I said that mathematical induction is what we use. It is used to prove or to check whether a mathematical proposition or theorem is what? True, or if a statement is true or false. So it is based on three principles, or three steps rather. Then we have, let me say, solution. The first one, we look at the base case. The base case is where we say let n equal to what? 1. So if we say that the sum n, let it be sum n, let it be the statement, okay? Or let this be the given statement, which is this particular statement, okay? So it means that what if I want to check when n is equal to 1, so we call that what the base case, to assume that n equal to 1 to base this particular statement if it is true. So it means that what we are taking the first term here. This is the first term. So when n equal to 1, we test this for proposition. So we have n, the first term there is 1, equal to, then we move to this place. So we have 1 square. Wherever n is, put 1. So this implies that 1 equal to what? 1. So it means it is true for the sum of the real integers. So now, the next one we are going to look at is the hypothesis, which is inductive hypothesis, which is where we assume that what? Where we assume n equal to k is what? True. So how do we do this? So it means that what? Wherever we are going to see n, we plug in what? K. Oh, so this here, this particular place here is to determine the next term that will follow after this given ones that are specified. So it means that what? I'm going to have my 1 plus 3 plus 5 plus plus. So in this place you put your k, wherever you see n, become 2k minus 1. Then you go to this side, it becomes equal to what? K squared. So as you can see, this statement is also true for this the sum of these integers, natural numbers. So what we do now, the next step is to test whether k plus 1 holds for this expression. So we're going to put when n is equal to k plus 1. So it means that we're going to plug in k plus 1 for n. So here we bring out this one here. We have 1 plus 3 plus 5 plus plus. Yeah, remember our k term, don't forget you bring it to become 2k minus 1. Then the next one we are going to have now is plugging in k plus 1 to obtain the next term that will be here. So which means we have 2 here, e to what? K plus 1. Then this minus 1 will be there. Minus 1 equal to. So on the right hand side, we're going to have k, plug in k there, k plus 1, then all squared. Alright, so we are going. Now, remember, from here to here was the answer I got, k raised to power 2. Remember, in our third step now, we are going to replace the whole of this place from here. It is the sum of these ones that we got this. So we're going to substitute this one. We could use this one to replace it, which means here I am going to have k square plus 2. Let us distribute this 2 here. Okay, if you distribute this 2, it will have 2k. Then 2 times 1 is what? Plus 2. Then minus what? 1. Alright. Then equal to this side. We have k plus 1 all squared. Now, here we're going to have a k squared plus 2k. 2 minus 1 is what? Minus, that's plus 1. Equal to what? K plus 1 equal what? K plus 1. So remember, our basic interest in this, our mathematical induction, is to make sure that our left hand side is equal to what? The right hand side. So in doing that now, my working now is to obtain this. So I'm going to concentrate more on this than leaving this one. Or I can as well just open this right hand side. So whichever way you want. See that you factorize here, or you put this bracket to obtain what is having here. Let's check if you are going to obtain what is here. If I open this right hand side, if I obtain what is here, it means the statement is true. But if for the other way around, I decide to use here, I work on this place, and I factorize here, I obtain something like this, it means that the statement is also true. So let us apply here, let us work on this for right hand side. I'll bring down the left hand side, k squared plus 2k plus 1 equal to, let's open the bracket now, k times k gives what? K squared plus k times 1 is what? K. 1 times k is what? K. 1 times 1 is what? 1. At the end of the day, I'm going to have a k squared plus 2k plus 1 equal to, here having k squared, k plus k is what? 2k plus 1. So the statement is true. So P or S, k plus 1 holds. So it holds for all the what? The sum of the natural numbers, starting from 1 plus 3 plus 5 till it gets to what? This. So this statement is true. So the statement is what? True. If you find this class very interesting, please don't hesitate to share this video, and do not forget to subscribe to my channel. God bless you. Bye.